Hey kids, this is Mr. Cozy, and this is video 16 talking about rational expressions. We're going to introduce the concept in this video, talk about common strategies for working with rational expressions, namely to factor, and then talk about the domain of a rational expression. So let's get started. A rational expression consists of two polynomials in a fraction. Okay, so an example is x squared plus x minus 12 over x squared plus x minus 6. Another example is x squared, a 5x squared minus 7x over 2x squared minus, let's say 50. Okay. So if it has a polynomial in the numerator and in the denominator, then it's a rational expression. And over the next few days, we'll learn several things about working with rationals. A great tip, though, starting out today, is if you see a rational expression, factor the numerator and the denominator. Okay, whatever you see, factor it. Now, in the next few days, I'll pull this back a little bit because there's a few situations where it's only helpful to factor the denominator. But in general, if you see a rational expression, your first thought should be to factor. So taking a look at this right here and this right here, looking at that rational expression, my first thought should be, x squared plus x minus 12. I need two factors of negative 12 that add up to positive 1. And that would be x plus 4 and x minus 3. Okay? And then looking at my denominator, that's going to factor into x plus 3 and x minus 2. Okay? A lot of the things that we'll learn about working with rational expressions only work once you have factored everything down as much as you can. Okay? So taking a look at this second example in the numerator, I have a GCF of x, so I can factor that out. In the denominator, I have a GCF of 2. I can factor that out. And then what's in the parentheses here, I can factor that because that's a difference of 2 squares. So I can factor this out more. Okay, factor it down as much as you can. If you see a GCF, take it out. If you factor once and you see that you could factor some more, factor some more. Okay, let's take a look at one more example with the factoring. Let's take a look at a 5 x to the 4th minus 5 over 2x squared plus 3x minus 2. Okay, let's factor that down. So I can factor out a 5 from my numerator. And then that's a difference of 2 squares. this is. And then this is also a difference of 2 squares, so I can factor it some more. So I can factor this all the way down to 5 times x squared plus 1 times x plus 1 times x minus 1. Factor everything down as much as it goes. This doesn't factor because it's a plus, not a minus. It's not a difference of two squares. Okay, let's look at my denominator. My denominator has a 2 as a leading coefficient, so you can do rewrite, or you can play the number game. I'm going to play the number game. So I need two factors of 2 and 2 factors of -2 that when I multiply them together and add them up give me positive 3. So let's go 2 and 1. And then I think -2 and 1. Wait, no. Positive 2 and -1. There we go. Because 2 times 2 is positive 4. Minus 1 is going to give me 3. Going diagonally, my 2 factors are 2x minus 1 and x plus 2. So 2x minus 1, x plus 2, 2x minus 1, and x plus 2. Okay? Whatever you see in a rational expression, you want to factor it as all the way down as much as you can, almost all of the time. I'll pull it back a little bit in the next video, but for the moment, factor. Okay, let's move on and talk about domain. Domain of a rational expression. Okay, here's the rule. No zeros in the denominator. So my denominator cannot be 0 at all. So my domain, it will always be all reals except for, and this slash is set theory for except for. I wrote expect. That should be except. Except for any x's that result in a 0 in the denominator. Okay? So, let's come up here and take a look at this rational expression. I ignore my numerator and look at my denominator. For what x's would this denominator equal 0? Okay, these are two quadratic factor. I'm sorry, two linear factors multiplied together. If you recall, and this is one of the reasons why we factor. To solve this, I take each factor and set it equal to 0, and solve each little equation. So this is -3 minus 3. X is -3 plus 2 plus 2, x is 2. So if x is -3 or +2, then I would have a 0 in my denominator. So my domain for this problem here is all reals except for -3 and +2. Now, if you recalled, the shortcut is to look at this number and take the opposite of it. And you can do that if you want, but be careful. Let's take a look at another one. over here, looking at this denominator. Okay, the 2 is not important because it will never be 0 because it's 2. X minus 5 is 0 if x is positive 5. X plus 5 is 0 when x is negative 5. So the domain of this is all reals except for 5 and negative 5. Okay? Time is short, so what I want you to do is to look at this last one and tell me what the domain is. Write it on a half sheet of paper and turn it in to me when you walk in tomorrow. Okay? I'm just about out of time, so we are going to stop here. Have a great day, and I'll see you later. Bye.